And our next speaker is ready to tell us about how to secure the architecture. This is Denis Tsvettsikh from EPAM. Hello, Denis. Hello. Before your speech, I was thinking about an ideal infrastructure. Is it possible to have an infrastructure that will tell designers right solutions, and there will be no way to break this infrastructure? Well, it's a dream of any architect, any designer, any dev. Yet, of course, it's not possible in reality. There are some architecture places. It can be some onion architecture, hexagonal architecture, and others. Now, the onion architecture themselves, they need to be tailored to a specific of a concrete project, and of course, delivering a template for all projects, which will be intuitive, and it will be so that it delivered hints to programmers, to coders. I don't know how to address this issue. Of course, it's good just to use your head and use your experience in this. Now, creativity of designers is something that we need to deal with. Of course, it will be not creativity delivered by designers, but also by architects, breaking a major system into components, how to organize links between them. It's quite a creative, way too creative process. Let's now that I go straight to your presentations. If we started talking about your architecture, we are going to run your presentation, and please, you have the floor. Today I will tell you how we can protect the architecture. I've been addressing this issue for several years for various companies and projects. I have gained a number of important experiences, and I'd like to tell you that this approach is going to be beneficial for me in my current and future projects. I will also help my colleagues to protect their architectures, and I'd like to share my experiences today with our listeners, with our viewers. Speaking about the quality of architecture, there are a lot of resources on clean, on onion, on hexagonal architecture, on DDD and others. There are few resources on how to measure the quality of a delivered solution, and we know the sustainability and abstractiveness from one of the books, how to protect the quality throughout the life cycle of the project, ranging from new participants in the project and from yourself, and when you start forgetting what you did a year later, a year earlier. There's few information about that, and I will tell you about it today. Let's look at what architecture is. Let's remember what it is. I will tell you about it, then I will tell you how to protect the infrastructure and why you need to protect it. And we also will look at examples of some cases I use to protect my projects. What is architecture? Briefly, let's look at what is architecture. This is the definition from the book Architecture of Software in Practice. It gives a very good definition that architecture means system components, internal, external interfaces, and component links. It is available on Amazon, and of course you'll be able to buy it using the link below. The architecture is something that is not changing, that is permanent. You just select it from scratch, whether it is like that or architectures are flexible. Those of you who think that architecture is permanent, put a plus in the chat. Those of you who think that it's flexible throughout the life cycle, please send a minus in the chat, and we'll see the results afterwards. Architectural changes, what is it? Speaking about components, adding or moving a project in solution means that you need to change the architecture. The architecture is also external interfaces. Of course, we are speaking about renaming or changing public methods signatures or changing access to public internal classes on methods. The same is for adding or removing a link on project or NuGet package. We see that the architecture is always changing. When we develop even minor features, we see that the architecture of the project is always changing. Let's look at how we can protect it and how we can secure it. Let's look at the components. In terms of quality, good components mean that we don't have any excessive components, we don't intend to make a project with minimum components. On the other hand, we shouldn't have excessive components. In one of the projects I saw some migrations, entity framework migrations. I didn't understand why they made such a solution, so there was a dedicated excessive component that we can do without. Clean or onion architecture is something that is about components. The bad news is you cannot automate this task. You cannot think up a template or a tooling that will be analyzing your components in the architecture. Vitaly mentioned it at the beginning of my presentation, and offer some solutions for a particular project. Programming is a creative task, and of course it's not possible to automate these creative tasks. You just have to think and try to use your experience. I reported on that on CodeFest, on our EPAM seminars, and I have a dedicated link, and of course I can share it with you. Of course it's not possible to automate it. As I've said, there are a number of templates for clean architectures. Some companies provide templates for microservices, yet at the same time these templates need to be customized, need to be modified after application. So the value of these templates are not that high, because you will need to refine them to some production state after you use them. The next thing is external interfaces. There are people who want to combine those components. You see that implementations and interfaces are within one component. In such a scenario, we see that the interface is public, meaning that all those who are referring to the component, while the implementation will be private. Again, those who refer to the component won't have the access to this implementation. There are other approaches who like dividing services and implementations components. So we have the service and implementations with implementation, and service and interface with the interfaces. Two separate things. The interface and the implementation can have a public identifier. For us, in such a scenario, it's no matter what kind of identifier we have. We will limit the use of these clusters to be able to enable clients to use those interfaces by controlling links between components. And please tell us in the chat what's your approach, whether you combine interfaces and implementations together in a single component, send a plus and send a minus if you divide them. My recommendation will be to split interfaces and implementations. We can, by this, to control all of them together. Such advice is feasible for applied SW. For libraries, they need to divide contracts of various components and remove some classes from that. We are checking implementations so that they don't refer to implementations. We don't want to have the reference from service implementations to another implementations. As a bonus, we have some very clear metrics and components, diagrams. If we calculate these metrics on sustainability, on reliability, and that was what was offered by Uncle Bob, and I had a dedicated report on that, and in the TechConf there is the link in the slide. There are some links. Of course, you still will need to have some unnecessary links. If we use some services from a different component, we won't be able to implement our logics without using these services. we can control our unnecessary interdependencies. Controllers can use dedicated repositories to bypass. Let's look at a number of examples. There are examples of incorrect links. Entities can use ORM directly when we have the Kubernetes and domain IITs. There is one more example on implementations. When implementations use cases from other implementations, handlers or use cases can directly use the main services implementation instead of using domains. There is one more example when controllers reach directly to infrastructure interfaces instead of delivering through use cases. Controllers, instead of that, deliver from the base and deliver them to the client. There is one more example of limitations. There is an error example when we have our use cases using infrastructure implementation. Our application logic here is linked to a dedicated infrastructure implementation. It can be an integration, and it can be a service base or some other examples. You will need to be protected from these links, from these references. The implementation of the infrastructure should refer only to dedicated interface components, while everything else, controllers, use cases, domain services, all this needn't have any references to that. There is one more case which is more complicated when we have a bigger project with several modules, with several backends and frontends. In such a scenario, when we have a reference using use cases from a different module, or whether we have use cases using application services from other modules, you need to protect yourself from such links and secure that there are no them. If we use bounded contexts, we will need to divide them. Bounded contexts, unlike modules of backends and frontends, can interact. They can refer to each other, yet it's quite important to provide this interaction via the contract. And of course, you need to be secured from avoiding contracts in such a scenario. Why is it important to control references? Let's think what happens if we disable references. In such a case, our project will turn into a mess. It will be a mess that is including many elements. We have the project that uses a single code, and it will be a big snowball that will be abundant in links that cannot be controlled by various parts of the system. How to secure, how to protect from themselves from this? We can control it by analyzing our references between projects. So we can analyze it by analyzing sets. And I'd like to tell you here that assembler reference appears not when you add it from one project to another, but when we use the code of one project in a different project, then it happens. We can check whether all the references are correct, whether we have a single incorrect reference or link. I'd like to tell you that we need to check assembler references and incorrect references, and of course it's good to use reflection for that. At the same time, we don't want to be connected to a dedicated IDE or eSharper. There are dedicated ready-made tools that are efficient in this. There is an additional bonus. Reflection helps analyze not only references between sets, but it's also possible to look at a particular set to find something interesting there. What kind of tools are there? We have architecture tests, we have a Roslyn analyzer, and we also have compiler tools. So let's look at those solutions. First of all, to analyze references between sets, we need a dedicated naming, we need a dedicated prefix. For each module we will need a name, for example module X. For each interface component we should also have a component that is added with .interfaces. For implementation it's the component for implementation components. For infrastructure we get the access to data, to service bases, and of course it should include an infrastructure word somewhere in the middle. This is something I use for my project. You can take it or you can use your convention. Probably it's good to run one major test that tests everything, or you can run a test for each incorrect reference. My approach would be to have a single major test because it has a lot in common. How will it look like? We see here that there are a number of implementations and frameworks. We see that there are different implementations. These are incorrect references. We load all sets of our projects that have the dedicated prefix and that are named in accordance with the convention, and then we run the analysis. So we check all layers. We after that look at all sets, and we look at those references that start with the dedicated prefix of our project. If we have one component in the assembly, we have a dedicated component in the reference. For a band reference we will have the result of cross-reference layer. For cross-module references, for references between bounded contexts, in case of various backends and frontends, the mechanics will be the same. We create a list of modules, public AP and others, and we conduct the checking. We check all the modules. After that we use the NetArc's test tool, which is a library for architecture tests. We check all types that are available in the names. We check it for one module. If they don't have references from the other module, and we check that such a test is successful. Should we use manual or NetArc tests? Probably it's easier to use the NetArc test, which can be used by default. Yet in this case we need to have correct namespaces that should be updated, and ReSharper is a good tool to do that. Manual tests can be helpful for geeks who want to analyze references between components. It can be helpful in case of a very complex naming convention. NetArc tests cannot do everything, and of course for more profound testing you will need to do them manually. The architecture tests can be run automatically on a build server. If you have a CI there, it's very easy to update them. There are new versions, they are not linked to a dedicated project, and there are no problems, no issues with switching, yet the disadvantages is that they work offline. There is an alternative which is online. It can be Roslyn Analyzer. There are some templates for studios, and of course it's possible to create such an analyzer for 1 hour. It's quite easy and quick. A Roslyn Analyzer for the same task will look like that. We have the list of components and list of incorrect links. Then after that we have some ways to create a descriptor. We will generate warning and error so that we can have a better result in case of a incorrect reference. We will analyze Roslyn. We will use the Roslyn Analyzer to change using directives. We have the dedicated approach, and we have this check, that is to check incorrect links, having the namespace, having the for each, and there are two parts using different parts of the incorrect reference, and if we do that, we get this error in the studio. The same will be for modules, so there will be bounded context in the tool. The same is for other modules. If we have the assembly in just one component, or we have a bounded context in one component, if there are two different contexts, we generate the error that we have a cross-module reference. Here is the error in the studio. If we get a component from controllers which is not intervened into a dedicated base, we use the topics that we have the cross-level reference error here. A Roslyn analyzer has a number of advantages. It works online, and we can see it from scratch when we run it. It has some flexible settings. You can set up warning and error. You can also publish it as a plugin or a NuGet package. There are a number of disadvantages. If you change anything, you need to provide updates for the entire team. For IDE plugins, it can work for all solution studios, studio solutions. It is configurable. You can disable the plugin. If we use the Roslyn analyzer, if we use it as a plugin, there is a risk that it will be disabled and do something in a wrong way to break our links. There is a third way to protect, which is the internals visible to attribute tool, which is helpful for multi-usable libraries. It's possible to divide it from external contract. It's very easy to use them for testing, to check classes, to check implementations. One implementations will be internal in such a scenario, and we can control the visibility. In such a case, if we use one component and we want to use each class in a different component, if it's not possible, our project will not be compiled. All classes in our project should be internal. In assembly info, there are components that can use such a case. We have the DDD context. We look at it and we configure the assembly tool. In the application, we have the composition group that registers all our dependencies in a container. It can access only it can access the context. If we use the DB in a different way, our controllers will not be compiled. It has a number of advantages. It's the most reliable approach. There is no chance to bypass these tests. Tests can be disabled, yet bypassing these checks is not possible for applied programmers. Such an approach resembles hacking, and of course there should be some other architecture tests to check other classes. That is checking internal classes, and they should stay internal. Now, in the second part, we'll look at design as well as architecture. There are a lot of opinions on architecture, whether architecture means design, whether things are the same. Send a plus. Those who don't think so, send a minus in the chat, and we'll look at the results. Uncle Bob says that architecture and design is the same in the community. We think in terms of architecture, in terms of components of the system, while when we talk about design, we are more focused on classes, which is a lower level class-based design, configuring a system. What are the methods to protect design? There are no bad calculations during the serialization. This is the first thing. There are external interfaces, there are conventions and namings, and we also work with a super type, with a layer super type, and we also need to comply with a contract. Let's look at all those cases. There is a typical case in many projects is that we have DTOs with IE enumerable properties. They can have several collections. You can use a list or an array to guarantee that these collections are real, and there will be no lazy logics of queries, and this serialization will not be stuck. We can create a dedicated test. For example, in 7 strings, we get all assemblies from with our prefixes. We derive all details. We derive all parameters and properties, and string and enumerable. We tell you in such a case that the test is unsuccessful because there are a number of conditions that do not comply. There is a similar situation when we have the business logic in this service. It returns a collection using the IE enumerable to get the array. We can create a similar test to test the same case. We get all the interfaces from these services. We also get all methods, and we look at the values that are returned. If the value is IE enumerable and it's not an array or a list, we see that our test is unsuccessful. This is a simple way to test. There is one more example when our implementations shouldn't be public. We have our interfaces that are public, while implementations should not be public if they are deployed in one space. We can create a check for that. We get all the types that are from different environments with our classes, and they shouldn't be public. This is something that we check. We check this condition, and we have this test here using the arctest tool. We also can check naming conventions, so we can have an iService interface and we have its implementation. In such a case, our class name is the same with the interface. This is good to have, not just for consistency, but also for addressing practical tasks, practical issues. We can use this convention to get an entity order name, and we can use it to build a service type, and then after that we can create its instance through reflections or derive it from a DI container. In such a case, we might have such a test when we have such interface and we check that their names end with the word service, which is to check the naming convention. We can also check the layer supertype. We can work with all exceptions, and we see the exceptions that are generated by our apps. They should have legacy from minor exceptions. Whether we can address it in a different way to be able to dive deep into the framework, we get all the supertypes that are in the current domain, and they should end in exception. We need them to inherit them from our class. We check it whether this condition is complied with. We need several strings of code to implement a very helpful thing for our project. And the last thing we can check, and I'd like to tell you about it, is the principle on Lisk's subclassing. There are a number of ways, and I like the approach of Ward Cunningham. The principle is about using derived class objects instead of base classes, base instances. In this case, they should be consorted in compliance with the base instance contract, and there is the link with this definition. Here we are talking about programming by contract. If we implement an interface inheriting from a base class, we don't have a chance not to use the properties and the interfaces in the classes interfaces. The compiler will make us do that. Our contract programming tells it that we shouldn't just inherit all this. We should also have similar exclusions from this inheritance. And our return values should be the same. For example, if there is a toList method, its value should not be null, should not be nil, and then of course there should be similar methods measuring the internal state correspondingly. If it has the ilist.add method, then it should increase the number by 1. There are a number of tools there, and of course we have the dedicated contract tests. You can use the netarc tests tool, not just a way to create tools and use it as a filter to work with different criteria. We can use it, we can look at it, and we can work with different types that implement the interface we want, the iService interface, and then we get instances, and we create our own instance and create the getValue method for it. We then check that getValue is not nil, and we want to check this state. We want to generate the exclusion we want. The key thing here is that all the implementations from the iService behave in the same way in all cases we need. We check that they comply with this principle, and they behave in the same way in similar cases. That's it. That's it from my side. I'd like to draw a number of conclusions. So we looked at the architecture, we understood that architecture means components, interfaces, and links, references. We also understood that we need to have a good architecture, a good system, and it's a creative task. It's not possible to automate, and there is no universal solution or tooling that could help us create a project template dedicated to some concrete requirements. So we divide components by abstractions and implementations, not to be able to check everything. When we have this division, they can all be public, and of course it will not break our architecture. At the same time, we create and check references between layers and modules. How do we test? How do we check? There are manual or automatic task. It can be a Roslin analyzer, or it can be attributes that we talked about. There are a number of ways to control architecture. We can also control architecture and its components, and we also look at behaviors. This is just a dedicated example. There are some external interfaces that comply with our expectations. We want to conceal everything we don't need, and we have this internal identifier. We also can check our naming conventions, otherwise our reflection will fail. And we also look at the relevant layer supertype. We also check compliance with the contract for classes. It can be exceptions or returned values or changing states. There are some our own customized options. We've automated some of them in our projects. You can add your own. Of course, this list can be expanded and should be expanded. The key message I want to deliver today is that architecture tests are a good and very helpful code. 20% of features addresses 80% of our user tests, and of course it's good. Architecture tests provide helpful solutions to tech leads or architects. They reduce review time. They also protect us from recurring errors. Of course, it's possible to avoid errors delivered by new participants of a project who don't know the specifics. These tests help us secure that there is basic ideas in the project, and they ensure compliance with these ideas. There are a number of materials, reference materials. There is an example of code at GitHub. You can look at them, you can look at architecture tests created online and run through NetArch tests. So you can look at Roslyn Analyzer, and you can also use internals visible too, using this link, using this repository in GitHub. I told you about the NetArch tests, which is a tool for architecture tests creation, and there is a dedicated link there. There are some additional resources. How to make a good architecture. There are a number of resources online. Not all of them I can recommend yet. I can just probably share with you some of my own materials. These are high quality materials and they are representational. I told about them at EPAM conference, at CodeFest, and we have this GitHub link, GitHub reference. You can look at it, you can look at the experience. Today we talked about some architectural metrics, how to assemble them, how to analyze them. I also had a dedicated report on that at the TechLeadConf. This is a topic which is relevant for the quality of infrastructure, yet it's a different tool, it's a different instrument. You have my link to my presentation. If you're interested, if you didn't have enough time to understand, you can copy this QR code and look at my slides. What should we do next? There are some next steps. You now have the information how to secure your architecture and why you need to do that. What should you do about it after that? The key thing is you can create a test to test references among layers. There are a number of concerns regarding the project safety in such a case. If you have a major project, you can add some tests to check references between modules in backend and frontend. You can write tests for IE enumerable, or you can run a different test. You will need it to understand that you don't have a lot of returning IE enumerables. You can also try the internals visible to. It's not hacking as it might seem, but it's a convenient tool. You can also try to create a Roslyn analyzer. You just spend like 70 strings, like 2 strings of coding. It's quite simple. That's it from my side. Thank you for your attention. If you have any questions, I would be ready to take them right now. Thank you, Denis. You had a very informative presentation and it was quite insightful. And I also know that you have a lot of reports on architectures. During your presentation, our participants commented in the chat, many say that architecture and design are merged together. And of course, we need to understand that a lot of people just merge architecture and design and that's it. Yes, I agree with that. Architecture and design are just 2 words that are understood as the same word by many, and Uncle Bob says like that. In talking with people, I try to understand what people mean by that. Architecture, whether it's a high-level design or a low-level design, so we try to be more specific when we talk to each other to be able to understand what we mean by architecture and design in specific modes. Did you have any experience in implementing architecture tests to existing projects in production for several years? Yes. It's an experience that is quite insightful, quite helpful. We had a major project of the ERP system. We decided to split it into minor bounded contexts. They were irrelevant with each other chunks, and there we needed those architecture tests that were helpful in such a scenario. They helped us to avoid interferences between bounded contexts. And these high-level tests were quite helpful, quite a good tool for that particular project. If you start a project from scratch, if you don't have a ready-made team with some new engineers, then of course it's good to use those design tests. For example, a return of IE numerable or IE, which could be an IE curable. Those design tests, in my opinion, are quite relevant, are quite beneficial, and they help us get accustomed to all conventions, to all arrangements within the project. Now, okay. In our chat, they ask you for tests which calculate incorrect links, should we add new cases with new projects to the solution? How do we not forget to do that? Well, architecture tests are not that different from other tests. It is also code that you will need to support through the broad project lifecycle. You can set a reminder for yourself so that you do that once every 2 weeks. So when you have every new sprint, you can use them. You can use those links regardless of whether you have new projects or not. This should be a regular activity for all project developers. And we also probably can run a test that will check that all namings are in line with the convention. Yes, it will be helpful, of course, as well. And will be a red flag if there is something new, and meaning that we need to do that. Now, with conventions and namings, we didn't have a lot of issues. For designers, they like conventions, they like consistency. And of course, they like this naming when we have all components named with interfaces, related to interfaces, and with implementations we have implementations in naming, so there are no major issues with conventions compliance. I don't remember it from my practice. While with new components, and you need to update the tests, it's not often, but it can happen. Conventions might change, and this might lead to incorrect links that are bypassed by testing, so we will need to monitor it on a regular basis.